The National Electrical Code does not specify a maximum number of grounding conductors that can be placed under a screw on a 200 amp service ground bar. However, some general guidelines should be followed. Firstly, use common sense, avoiding overloading the screw by placing too many grounds under it. Secondly, follow the manufacturer's instructions. If the manufacturer provides specific guidelines for the number of grounds per screw, then follow those instructions. Thirdly, leave some slack in the grounding wires to allow for movement and future maintenance. The requirement to connect grounds to a ground bar is found in National Electrical Code Article 250.60. This section states that the equipment grounding conductor shall be connected to the equipment grounding terminal or grounding conductor connection point within the equipment enclosure, or to the grounding terminal of the receptacle supplying equipment within the enclosure. While this section does not explicitly mention ground bars, it is generally accepted that a service ground bar is an acceptable grounding point for multiple equipment grounding conductors. The intent of grounding is to provide a low impedance path for fault current to return to the source, which in turn helps to quickly trip the circuit breaker or fuse protecting the circuit. Effective grounding minimizes the risk of electrical shock and fire. When installing grounding conductors on a ground bar, several factors must be considered. One is the size of the grounding conductors. Grounding conductors must be sized according to the requirements of National Electrical Code Table 250.122, which bases the grounding conductor size on the size of the overcurrent protector device protecting the circuit. Another consideration is the type of grounding conductors. Grounding conductors can be either solid or stranded, and they can be made of copper or aluminum. Copper is the preferred material for grounding conductors because it is a better conductor of electricity and is more resistant to corrosion. Aluminum grounding conductors are permitted, but they must be sized larger than copper grounding conductors to provide the same level of protection. A further consideration is the type of connectors used to connect the grounding conductors to the ground bar. The connectors must be listed for use with grounding conductors and must be properly installed. Improperly installed connectors can create a higher resistance connection, which can impede the flow of fault current and increase the risk of electrical shock and fire. When connecting multiple grounding conductors to a single screw on a ground bar, it is important to ensure that each conductor is making good electrical contact with the ground bar. This can be achieved by using star washers or other similar devices to ensure that the conductors are tightly clamped to the ground bar. It is also important to avoid over-tightening the screws, as this can damage the ground bar or the conductors. When working with electrical systems, it is always important to follow safe work practices. This includes wearing appropriate personal protective equipment, such as gloves and eye protection, and energizing the circuit before working on it. If you are not comfortable working with electrical systems, it is best to hire a qualified electrician to do the work. The National Electrical Code is a comprehensive set of rules and regulations for the safe installation of electrical systems. It is updated every 3 years, and it is important to stay up to date on the latest requirements. The National Electrical Code is available for purchase from the National Fire Protection Association, and it can also be accessed online. Grounding is a critical aspect of electrical safety, and it is important to understand the requirements of the National Electrical Code. By following the guidelines outlined in this video, you can help to ensure that your electrical system is properly grounded and that you and your family are protected from electrical shock and fire. In summary, while the National Electrical Code does not explicitly limit the number of grounding conductors under a single screw on a ground bar, you should prioritize safety and good workmanship. Firstly, avoid overcrowding. Secondly, follow manufacturer's instructions. Thirdly, ensure proper connections. Lastly, consult National Electrical Code Article 250 for general grounding requirements. Remember that proper grounding is essential for electrical safety. A ground bar is a metallic strip, usually made of copper or aluminum, that serves as a common connection point for grounding conductors within an electrical panel or enclosure. Its primary function is to provide a low impedance path for fault currents to return to the source, thereby facilitating the quick operation of overcurrent protection devices like circuit breakers or fuses. This rapid response is crucial for minimizing the duration of electrical faults, reducing the risk of equipment damage, and preventing electrical shocks. Ground bars are typically mounted inside electrical panels or enclosures and are securely connected to the building's grounding electrode system, which may consist of grounding rods, metallic water pipes, or other approved grounding electrodes. The grounding electrode system provides a direct connection to the earth, ensuring that fault currents can safely dissipate into the ground. Grounding conductors from various circuits and equipment are then connected to the ground bar, creating a comprehensive grounding network throughout the electrical system. These grounding conductors can include equipment grounding conductors, which connect to the metal enclosures of electrical equipment, and grounding electrode conductors, which connect the ground bar to the grounding electrode system. When a fault occurs, such as a short circuit between a live conductor and a metal enclosure, the fault current flows through the grounding conductors to the ground bar and then to the grounding electrode system. This low impedance path allows the fault current to quickly reach a level that will trip the circuit breaker or blow the fuse, interrupting the flow of electricity and preventing further damage or injury. The size and type of ground bar required for a particular installation depend on several factors, including the size of the electrical service, the number of circuits, and the applicable electrical codes. Ground bars are typically rated for a specific capacity, which indicates the maximum amount of current that they can safely carry. It is important to select a ground bar with an ampacity rating that is sufficient to handle the potential fault currents in the electrical system. Ground bars are also available in various sizes and configurations to accommodate different numbers of grounding conductors. Some ground bars feature multiple rows of connection points, while others have a single row. The choice of ground bar depends on the specific needs of the installation. When installing a ground bar, it is important to follow the manufacturer's instructions and all applicable electrical codes. The ground bar should be securely mounted to the electrical panel or enclosure, and all grounding conductors should be properly connected and tightened. It is also important to ensure that the ground bar is properly bonded to the building's grounding electrode system. Bonding is the process of connecting metallic parts of an electrical system to create a continuous electrical path. This helps to ensure that all metallic parts are at the same electrical potential, reducing the risk of electrical shock. Ground bars are an essential component of a safe and reliable electrical system. They provide a common connection point for grounding conductors, facilitating the quick operation of overcurrent protection devices and minimizing the risk of electrical shock and fire. When installing or maintaining an electrical system, it is important to select and install ground bars properly and to follow all applicable electrical codes. In addition to the physical components of a ground bar system, it's crucial to understand the principles behind effective grounding and bonding. Grounding and bonding work together to create a safe electrical environment by providing a low impedance path for fault currents and minimizing voltage differences between metallic parts. Grounding refers to the connection of an electrical system or equipment to the earth. The primary purpose of grounding is to provide a reference point for voltage and to help stabilize the electrical system. Grounding also helps to protect against voltage surges caused by lightning or other transient events. Bonding, on the other hand, refers to the connection of metallic parts of an electrical system to create a continuous electrical path. The purpose of bonding is to minimize voltage differences between metallic parts, which can reduce the risk of electrical shock. Bonding also helps to provide a low impedance path for fault currents, allowing overcurrent protection devices to operate quickly and effectively. In a typical electrical system, grounding and bonding are achieved through a combination of grounding electrodes, grounding conductors, and bonding jumpers. Grounding electrodes are used to connect the electrical system to the earth. Grounding conductors are used to connect equipment and other metallic parts to the grounding electrode system. Bonding jumpers are used to connect metallic parts together to create a continuous electrical path. The size and type of grounding and bonding conductors required for a particular installation depend on several factors, including the size of the electrical service, the type of equipment being grounded, and the applicable electrical codes. It is important to select grounding and bonding conductors that are sized appropriately for the potential fault currents in the electrical system. The National Electrical Code provides detailed requirements for grounding and bonding in Article 250. This article covers a wide range of topics, including grounding electrode systems, grounding conductors, bonding jumpers, and equipment grounding. It is essential for electricians and other electrical professionals to be familiar with the requirements of Article 250 to ensure that electrical systems are properly grounded and bonded. Improper grounding and bonding can have serious consequences, including electrical shock, fire, and equipment damage. It is important to take the time to understand the principles behind effective grounding and bonding and to follow all applicable electrical codes and standards. Regular inspection and maintenance of grounding and bonding systems are also essential to ensure that they are functioning properly. This includes checking the connections of grounding and bonding conductors, inspecting grounding electrodes for corrosion, and testing the impedance of the grounding system. Any problems that are identified should be corrected promptly to maintain the safety and reliability of the electrical system. In conclusion, grounding conductors connected to a ground bar must adhere to the National Electrical Code guidelines. While the National Electrical Code doesn't have a limit, safe electrical installation and maintenance should be prioritized.